The moment I switch on my lamp, I can see the light. We know the light has a speed of almost 300,000 kilometers per second in a vacuum, so it appears to travel instantly over a short distance. But 300 years ago, the speed of light wasn't common knowledge. We weren't even sure the light had speed, let alone a finite and a measurable one. So, how did we measure the speed of light for the first time? Well, allow me to enlighten you. In the 17th century, a Danish astronomer, Ole Rømer, noticed something strange when observing the eclipses of Io, one of Jupiter's moons. The eclipses were said to happen every 42 hours, but sometimes they seemed to appear sooner or later than scheduled, by up to 11 minutes. This discrepancy seemed to repeat itself, like a cycle, and Rømer saw a pattern. Eclipses happened later than scheduled whenever Earth was farther away from Jupiter in its orbit. He concluded that the inconsistency happened because light had a finite speed, something that wasn't commonly accepted back then. Here's a model of Earth and Jupiter orbiting around the Sun. The distance between Earth and Jupiter in this arrangement is less than in this one. The difference in these two distances is the diameter of Earth's orbit, so the difference in the time it took for light to reach us will be equal to the time it takes for light to travel that extra distance. We can try to calculate the speed of light in a simplified model, only with the knowledge and tools that were available to Rømer in the 17th century. Let's say we're on Earth at this point, and observe the eclipse happening 11 minutes earlier than scheduled. A few months later, here, we observe the eclipse happening 11 minutes later than scheduled. Like before, this difference in time will be the time it takes for light to cross the diameter of Earth's orbit, which we will approximate as 300 million kilometers. With this given information, we can now start calculating speed, which is the change in distance over the change in time. So, by putting in our values, we have found the speed of light as about 227,000 kilometers per second. By dividing our value by the value we know is correct, we see that we were able to calculate the speed of light with 76% accuracy. Now, what we did was very simple, but the importance of this scientific breakthrough was not in its calculations. It's in the revolutionary way that Rømer thought about light in the 17th century. His discovery of the finite speed of light laid the foundation for so many scientific advances that came after. It's thanks to those discoveries that we can now transmit data as pulses of light using fiber optics technology. It's really interesting to learn about the history of science and to read about the research processes that earlier scientists went through, because it helps us adopt the same out-of-the-box thinking that has led to all the progress today.